Hello, is my voice clear? Okay, thank you. So good evening, everyone. We'll wait for 3-4 more minutes and we'll start. Okay, so today's webinar is how to transform your classroom into a STEAM classroom, right? So today we are going to explore some practical activities. I have few projects with me, some classroom strategies we will discuss, and we'll discuss that how in a simple way we can make the learning more engaging for the students. So STEAM education is not only about, technology and robotics. It is about helping the students thinking creatively, solving the problems, collaborating, and learning through hands-on experience. So today's session will be mostly on activity-based learning and project-based learning. So I would really like to start with one question, that how many of you educators are already using the activity-based learning? Answers are welcome in the chat box. Is my voice not audible? You can show a thumbs up if it is fine. Okay, thank you. Okay, fine, fine. Okay, back to the question. Okay, my question is that how many of you educators are already using activity-based learning? Okay, all right. Ashwarya ji is saying that we are using activity-based learning. Great, great. Okay, okay. My second question is related to that only. What comes in your mind when you hear this word STEAM, specifically because STEAM is all about activity based learning, right? So, what comes in your mind when you hear the word STEAM? Any project, anything which you have already worked on or which you are working on or you are thinking about working? What do you understand by STEAM? Or what comes in your mind when we hear this word STEAM? Because right now This is really creating a fuzz in education industry also and in education department also, right? STEM is a problem solving using cross domain knowledge. Yes. Okay. Science and technology, engineering collaboration. Okay. Okay. Anshu, you are telling me the full form of STEAM. Okay. So STEAM is nothing. The full form is fine. The science, technology, engineering, art, and mathematics, right? But STEAM, whenever we hear this word STEAM, it always creates a project, an idea in our mind that every single thing, if you'll see, every single thing, every project, every activity, it is anyhow collaborating two or three subjects all together and making the teaching style more better, right? Innovation, hands-on practice, yes, practically knowledge, yes. So I always give this theory that let's say for example, if we are talking about gravity, right? So nowadays what we are doing is, okay, gravity is this, what is the value of value of g and so. But what Newton did when he realized what is the theorem of gravity, when something practically happened, right? And we as an educator and students, being a student, they don't know that what is the practical example of that, or how it will be practically done. They know the theoretical concepts and theorems, what is being taught, that is completely fine. But my question is that every single theorem is coming because of the practical things, right? The errors are coming because of the practical, then again the experimentation is going on. So this all comes under the STEAM. It's all about hands-on experiences, learning from your mistakes, and experimenting and innovating all the time, right? Yes. Okay. So that is why today's student actually needs the creativity, the critical thinking. These are some of the 21st century skills which we always talk about, right? Problem solving skills, rather than going for the memorization part. Okay. Why education needs the transformation? This is really very important to discuss. Why STEAM should be involved in education. Education is fine. Education is a part of our life, right? But this STEAM, where it lies, so according to me, it lies everywhere. It was never out of part from education, right? It was always a part of education. It's just that this term has introduced, and now we are more realizing that, okay, everything is relatable, but we are not talking about the practical examples, right? So, can anyone share any one activity where you're combining any two subjects together? Anywhere we are combining any two subject, three subjects together for showing any activity. Anybody of you? Any activity, because many of you have said that we are using activity based learning. So yes, any activity, can you please name it? Come on, educators. Good afternoon, Gitanjali ji. Robotics. Okay, fine. Number system in computer with mathematics as I use math lab equipment. Okay. IT and arts. Okay. Wow. Many of the things, huh? Chemistry Rangoli. Wow. This is something very nice. Chemistry Rangoli. The name is quite interactive, no? Okay. Physics, chemistry, and robotics. Okay. All right. So there are many activities you can name, definitely, which is combining two subjects or three subjects or the whole STEAM over there, right? So this is very important to understand that why education needs this transformation, right? To make sure that the students learn through activity, they are exploring all of it. They are exploring, they are not just doing the rote learning, they are exploring each and every topic, right? You have to make sure that the students are getting engaged in many of the subject. They shouldn't have any kind of fear of the subject, right? They should be getting engaged by understanding the models, the activities, the theorems, right? And I think that we should, it's a high time that we should shift towards the skill based learning approaches. Don't you think so? Smart dustbin came click. Okay, I would really like to show you here. I have many activities put over here. I'm going to show you one activity. Just allow me. Just see if the camera is properly faced. Yes. So here, yeah. So it's a simple model. Many of you as an educator has worked on this model of showing planets. You will say, what is big deal of showing it? I'm just trying to show you a model where all the terminologies of STEAM is actually getting together, right? So what do you say? Anything related to this? Anybody has made this for your students, or your students has made this kind of project? Because it's a very basic project, simple. We have done some creativity related to it. One more important thing is we are rotating the earth also. So here you can explain the concept of science, which is circular motion and the rotational motion, right? There are many things. Can't see your cam. Is this, can't see the model? Okay. Is my camera not working? Am I visible to you guys? Am I not visible? We only see the screen. Okay, just a second. I'm just stopping sharing the screen. Can you see me? Am I visible to you? Okay, let me check. My picture or me, because my camera is on properly. Okay, let me check with the team. Just give me 1 minute, please. Sorry, everyone. Am I visible now? Thank you so much. Okay. Okay. All right. Okay. Thank you. Okay. Let me show you the model again. There you are. Here. So this was the switch over here. I turned it off. Let me show you this model. This model is a very basic model. I'm very sure that you educators have created this kind of model to show the solar planet over here, right? So this here we are showing the rotation. Here we are including all the concepts of a steam. What I'm doing is I have taken the help of a little bit technology as well. So here what I'm doing is I have introduced a gear motor over here. And the switch over here, I'll just turn it on. There you are. I'm just keeping it over here. So what we are doing is all the planets are shown over here. It's rotating. This is representing the sun. And here you will see the earth is coming here. Okay. And the earth also is getting rotated. Like the here it is showing the rotation. See. And this is showing the circular motion and this is showing the rotational motion. So yes, now my question again is, now you are seeing this. Have you created this kind of model? I'm very sure many of the educators would have created this kind of model. Okay. Then maybe for someone here, I have given you a small idea, right? To just showcase it, right? Okay. So I have many models over here. One by one, I'll show you a few of the models. Okay. Thank you so much. Just let's keep this aside. Now here comes. I'm very sorry. I didn't knew that my screen, I was not visible. Okay. I'm again sharing my screen. Just let me know if you can see it. Okay. So as I've written that we should move from teaching content to just creating the experiences, and our audience is our students, right? So we have to work in that particular area to tell them to whatever concept you are introducing. I believe that first we should always start with the activity, uh, questioning them what they know about it, right? And then after introduce the models, ask your students to create such kind of models so that they would be, they would be getting involved in this term STEAM. STEAM is not only the abbreviation, it is all about the experiences, right? Every single time I repeat this, I know, but yes, this is kind of truth, right? So now my question is, how many of you teachers have tried project-based learning activity? I came to know project-based learning, or do you know the meaning or the difference between project-based learning and activity-based learning? Anybody of you, please answer. Any answer is welcome. PBL, okay. Project-based learning. What is the difference between activity-based learning and project-based learning? This is the basic question. Or anybody of you is already doing the project-based learning. Like many of you have said that you are already in activity-based learning. You are using it on regular basis. Floating and sinking activity. Yes, right. This is quite a very basic one, but every single time I find it very amazing and very, very interactive. The floating and sinking one. Okay. Project is when which the student prepare by themselves. Yes, right. Water sustainability. Okay. Activity is doing something to learn a concept, and project is learning through solving a meaningful problem. Actually, thank you, Anshuji. Yes. Activity is something just to explain a concept. You're showing an activity. And project is something, let's say, for example, the floating and sinking, which Arpita ji has said. Yes, floating and sinking is one of the activity, right? Where we are clearing the concepts of floating and sinking. Now, the project is if a student has understood the activity and using that concept to, to create a project or a model out of it. That is project based learning, right? Let's say, for example, I have shown you the model. The model is basically have shown many of the concepts over here. It is showing the science concepts, or it is actually taking all the concepts of STEAM, right? But this is a project. This is a project based model. It's not activity based. Activity will be that we are telling the rotation with activity. Let's say, for example, we are telling the circular rotation with activity. Circular rotation means we are telling them the example of giant wheel, for example, right? Or the swing which goes round and round. That is a circular motion. That is a activity based learning. But this creating the whole model or consisting STEAM, and taking it into and keeping it in the mind while and giving the solution for the problems as well. That is a project based learning, right? How plant grows from seeds, that is sprouting of seeds, which is project based and practical based. Yes, correct, right. Okay, jigsaw learning. Yes, there are multiple things which are which multiple not multiple, every single thing is related to STEAM only, right? Okay, yes. So science, technology, engineering, arts, and mathematics, right? So what it does is hands-on learning, as we have already discussed, right? It what it does by doing hands-on learning is we are giving chances to students to experiment. We are giving chance to us as an educator to experiment everything, to build, to discover, and to innovate, right? Not just listen and memorize the concepts. No, a big no, right? Creativity, whatever has been done, now use your critical thinking and then create something and then innovate something. That is quite a terminology for project based learning as well, right? Thinking is really very important when we use the term creativity, right? Solving the real world problems, like there are multiple examples over here. I was once seeing Manak Award. I'm sure many of educators know about the Manak Awards. It's a government competition, right? There I was just exploring that which kind of projects has came this year and so and so. So one student has given just an idea. Might be I have shared in the previous webinar or something. Somebody new here already will get to know something new. So that was just an idea, and now many of the malls and hotels are actually consisting this idea of keeping all the basins height wise, right? It was just an idea which came into mind of a little girl, and it got appreciated in the competition like Manak Award, right? It's a quite of a big success for a little student just for a good idea. And now the society is, because the student actually observed the problem, one of the problem, right, in the society, and then thought something what can be created. There is nothing as such rocket science in that, right? It was just an idea, but the idea actually worked. It got patented as well, right? So there are multiple things which comes under STEAM. There can be any idea. It's just about the creative thinking and thinking towards, I always talk about SDG goals, right? Sustainable development goals. So whenever you educators are working or your students are working along with you, always go for all 17 SDG goals and make sure your project lies into it, right? And collaborating. Always go for it. One single person can't do anything. When we talk about the projects, we should involve the students, make a team. They should be learning about the collaboration. One person can do everything, that's fine, but that person can face the challenges in future while collaborating, right? While having a buildup of, team collaboration or communication. Now, that kind of thing is very important for a leadership skills, right? Let's say, for example, if you're building a drone, so there are multiple things which will be getting fit over here, or anything, any model you can take, which can get fit in science, technology, engineering, and mathematics. I have just taken a real life example of drone. That was science. Science was like flight principle. Technology, we are using the coding and the sensors. Engineering is structuring the design. Art is the aesthetics. The project has been built up and giving the shapes. And mathematics is always everywhere. That is calculation, right? Any of the real life example you want to give for a STEAM, and or whatever your student has created, only one project. Any one project which your student has created under SDG goal or STEAM, keeping the concept STEAM in mind. Carbon cleaning. Wow, that's quite a nice thing to hear. Composite making, smart parking. Okay. I have one obstacle avoider also. I'll show you that for sure. Okay. Rainwater harvesting. Okay. Green hydrogen, water conservation. Okay. There are multiple ideas, there are multiple projects where you can showcase the talent, and you can showcase all the concept of STEAM, weather forecast, plastic. Wow, many of the projects you guys have already worked on, right? Smart city model. Wow, smart city is quite a, quite a big project, and there are multiple things we can do over there. Quality of air monitoring. Wow, which sensor you have used in quality of air monitoring? We see the food making process with steam. Oh, okay. All right. Smart glass for visual impaired. Wow, very nice. Many of the projects you guys are already working, so you are already knowing that how STEAM is getting involved in the classroom, and it was there all the time. How it is getting recognized nowadays, right? Okay. So that is what we here we are just breaking the barrier of traditional classroom and STEAM classroom. So it shouldn't be teacher centered, it should be student centered. It shouldn't be, just a rote learning or just a memorization. There should be exploration and inquiry. What, how, what if, right? There should be questions from the students, and they should be given opportunity for exploring and inquiring. There shouldn't be theory heavy. I completely understand that the writing and everything, and the big theories are very important, but it shouldn't be limited to the just theory based things, right? They should be given the practical and hands on learning. We educators also need this very very, it's very important for us as well. Single subject teaching, subject is fine, but there should be cross disciplinary. They should know that how subjects are actually interconnected, right? How they can be interfaced, and we can create something new out of it. There shouldn't be any fixed single correct answer. No, never. Always there should be multiple answers, and there should be, I think, wrong answers as well, for the better experimentation, right? So there are some things which we can do, like group discussions we can do, where students can put their ideas in front of everyone. It can actually develop and develop many skills under them, like communication skill, keeping your point out of there. If a person is introvert, they can, they have to work on their interpersonal skills as well. Project and activities, they should be learning by doing. This is really very important. One of the project I will show by learning by doing as well. Okay, how we can learn by doing, how we can build something, how we can present that particular thing, right? Technology integration is really very important. These three which I have written is actually getting together, and where if somebody is taking this together, the student or an educator can actually cope up with the good ideas, right? Can come up with the good ideas, and they can actually create something, and then they can present also. right? We should use the digital tools to amplify the creativity, like many simulators I have already told you. The same simulator I will show you today also, so that I can keep you reminding that go and check the simulators. Tinkercad is one of the very good simulator for testifying the circuits, right? PHET I have already told you. So please go and visit those sites. These are really amazing and very important, and we can do experiments over there as well, right? So some of the features I am going to tell you, and then after I'll show you some of the activities as well. So feature of the STEAM classroom, what it looks like is student is creating some models or prototypes. It should be always team based, as I have it should be project driven, right? If anything, if any student is not participating, there should be active participation of all of us. And being a mentor, we as a mentor should be giving our 100% if a student is that much interested, right? There should be open ended problem solving challenges. The student should be, or educators should be, giving the chances for questioning, right? Let me share my screen to you guys, just a second, where I can show you one platform. I'm sure about maker spacers. Just a second, I'm sharing my screen. Let me know if you can see my screen. Okay, all right. So there you will see many of the projects, right? I'll show you some of the projects here also. Many of small scratch related projects, just scratch materials are used, and models has been created over here. You can just scroll. I don't have sign in over here, so you can just see many of the projects. You can just search over here. You just click here and you will get to know about it, right? Many of the things has been created just using the scratch materials, right? See, a floating boat. Student has used only a simple foam and created a floating boat by just using a simple biomotor, right? Battery, motor, and switch. Simple, right? Here I'm going to show you just a second. Okay. My camera is visible this time. Let me know if you can see. Okay. All right. So this is a simple bot or anything you can say. I have used only the battery over here and one bio motor and created a simple, you can see there is no tire, nothing. Just showing the motion. That's it. Okay. So here I am. I'm not going to hold the battery in fact. See, see. It's a simple concept of battery and a motor, and what it is doing, it is just taking the whole thing, whole model, step by step, taking step ahead, right? It's a very simple model created by just using some Legos, right? So there are multiple things which you can do. Now, this was battery and motor, but this is not a battery or motor. This is also for the smaller students, right? But we see that this is just a chair kind of model or anything. But actually, what it does, it it actually enhance the gross motor skills of the small students. Don't you agree with it? If these sticks will be, this linker things will be given to the student, and you will say that okay, you have to create a chair, so there will be a creative thinking will start in the mind first, right? So how does it chair look, how it is getting balanced, what will be the, how I'm going to create it, how it will be, what will be the color of the stick, how we are going to create it, what will be the angle of the chair, and so many things. It doesn't require any motor, any circuit, nothing, right? It's a simple concept, right? So one I have showed with the motor, another I have showed without anything, just a linker thing, right? So there are multiple things which you can do over here for showing STEAM in every activity, right? Again, I'm sharing my screen. So that is what the maker spacers, you can see that it looks like, right? There are multiple projects are given as an educator. Please go and see that page. You can see our page as well. Many of the projects you will find STEM robot technology. You will see, you can see all the projects in your YouTube channel also. Okay. Okay. So what it does is you can create models, you can take help from there. You can ask your student, you as an educator can create a model first. You can ask your students to take help from here and create their own things, right? So my question again is, what small change you are going to make this week? Okay, the summer vacation is started, but still, okay. So in your classroom to make more interactive. Yes. Please share link for us after session. Yes, sure. I'll share all the links. Okay. Or I will share one by one here only. Just a second. Yes, my question remains the same. What one small change can you make this week or in the upcoming time to make your classroom more interactive? Um, any answer? More hands-on practice. Yes, this was I was expecting. More hands-on experiences students actually requires, right? Yes. So here you can log in also, you can register also, and your students can post their projects as well. This in on this site. Okay. Give problem statement for students to think about. Okay. Yes. Case scenarios, I think case scenarios are really very important to show, to give it to the students so that they can realize and they can think about it, right? Make them learn on hand. Okay. Right. So yes, Makerspace is one of the platform which I shared. It will allow your student to build, to tinker, to design freely, and they can post it as well. Okay. So here is one activity I'm going to show you, which is balloon rocket. First, I really want to know that anybody of you has created this activity for just for the experiment. More examples from surroundings. Yes, right. A small challenge to make new things. Absolutely correct. Yes, anybody of you, this balloon activity, anybody has already experienced it or showed it to the students or anything? Yes, no, just a simple answer. Yes, done by students. Okay, great. Wow. Okay. So how was the reaction? I would really like to know. Like they really like if there is any kind of activity based things, right? That is visually created and they are experiencing it, they are touching it, feeling it, and they are doing something by their own. Okay, I'm going to show you the screen, just a second. Yeah, just let me know if you can see the screen. So this is the balloon activity. I have already experienced it as well. Air occupies the space, right? So this is the activity. Just a second. I'll just show you over here how it is created. See, every single thing is given over here. How to, what materials are needed. That is not a very big thing, but yes, the concept will be clear for sure. So let's make it a little bit fast forward. The wool has been taken and just with the use of this straw, we are going to create a kind of a rope. This is something artistic things are given just to show a rocket kind of thing. Okay. You'll see just a second here. Right? It's just aesthetic things. Let's do the experiment. And this was the same thing, right? Just a second. So my question is, can you make it full screen? Sorry, it's done. Just a second. So now the question is, which balloon shape travels fastest and why? Yes. Anybody here can tell? Just a second. Is my screen visible to everyone? Okay, okay, fine. Okay, okay, thank you. Yes, my question remains same. Which balloon shape travels fastest and why? Oval shape. Pressure will not be divided equally. Okay, oval shape. Okay, all right. Jyoti G is saying it's not clear balloon activity. Okay, all right. I'll clear that concept. It can cross the air easily. Yes, oval shape. Actually, the balloon activity is a simple steam activity where balloon is actually moving forward on a string and air inside it is released, right? You will see, might be, I'm very sure there are multiple examples in the birthdays or something. We just blow up the balloon, and somehow it, if it is not tied up and the air goes, it goes here and there, right? So in this activity, what we have done is we have created it in such a way, and we have given a way to it, so the air is getting utilized to and pushing the balloon backward and going forward, right? It is actually a good example of Newton's third law, which is action is equals to reaction, right? So action is air rushes out and keeps the balloon backward, and reaction is balloons move forward. Like, what is the example of it? That is rocket, right? That is why people are writing oval shape, correct? So basically, it is consisting all the concepts like air pressure, force, motion. It is having the technology like understanding the rocket movement. Engineering is also here, like building and testing the setup. Decorating, we are decorating it. We are creating small, artistic things as well. We are measuring the distance. We are measuring the speed, angle. It's a good activity of explaining the STEAM concept. Jyoti ji, am I clear? Okay, all right. Fine. Okay, next activity, let's move to hydraulic bridge. So first of all, anybody of you, I'm very sure many of the educators have gone through this activity, hydraulic bridge. Can anybody tell about it? Okay. If somebody has created, can you tell me that how it is created related to STEAM? Bharti ji, yes, please go on. If you can write, just students have made it. Great. Nice. Pressure. Actually, it shows the hydraulic pressure over here. Yes. How it is created? Okay, first I'm going to show you the video, and then we will learn about the concepts, right? It is basically, the core concept is like hydraulic pressure and fluid mechanics has been used over here. And what we are doing is we are doing a mechanical movement, right? And we have designed it in such a way so that it can move, and it will show that bridge is getting apart and getting together as well, right? Just a second, let me show you this activity. I've created it as a full screen. Let's make it a little bit faster. The whole bridge model has been created. Now the syringes has been, and how it will be, the pressure is applied over here. The air pressure, the hydraulic pressure is getting applied, and getting released as well. Okay, all right. So yes. Syringe consisting of water. Okay. Okay. Any of the example you want to give? Any machine which works on pressure, like on the concept of pressure? There are multiple. Yes. JCB. Okay. Yes. Yes. Okay. Heart model using syringe. Yes, I have seen this model. It's quite a nice one. Bus doors. Okay, the hydraulic ones. Yes, correct. Hydraulic car lift. Car brakes. Car brakes are also using the hydraulic concept, right? The lifts, hydraulic lifts are there. Syringes, excavators, cranes, water pumps. Many of the examples are there. Many of the projects are there, which is already working on hydraulic pressure, right? Yes. Aircraft brakes. Yes, right. So basically, it is getting used in many of ways, right? Okay. Third activity I really want to show, paper circuit activity. First, again, the question is, how many of you has created this? Now, first activity was having science and mathematics all together. Here, second activity, hydraulic bridge, is having engineering and physics mostly. And the third activity is having science and engineering, right? We are using the copper tape over here, coin cell over here, and LED, right? So many of the concepts is getting covered over here. How the conductor and insulator can be used, right? What is conductor, what is insulator, right? And what will be the circuit connections, and if there is any kind of problem, how you can troubleshoot, how to create a circuit, what is the series and parallel. There are multiple things which you can learn over here and you can relate over here, right? So first, before showing the video, I would really like to know, anybody of you has already created anything related to paper circuit? Any of you has created anything which is based on paper circuit? It's a very nice example of a STEAM, right? Greeting cards. Wow, nice. Birthday cake with candle. Okay, yes, okay. All right. So it means you guys know about it, and it's a very normal. And in fact, you can, if you, copper tape is very easy to find on the stores. You can definitely, if you haven't created yet, please do try. It's the easiest example and easiest activity you can do at home, right? Study lamp and so, yes. Multiple projects, right? Let me show you. Simple drawing. And here what we have done is we are creating a switch, kind of, we are creating a path of switch. Okay. Oh, sorry. Here started making the circuit, which is using the copper tape. The positive and negative side of LED is very important to understand. Coin cell is already placed over here, and here what we are doing is that we are turning on the switch and turning off the switch by just sliding it. We have made a slider switch of our own, right? So what is happening? Before it was a before it was an open loop circuit, and when the switch comes towards the circuit, it becomes a closed loop, and then resulting in the eliminating of light, right? Okay, there you are. So what exactly you understand from this? The concept of science and engineering, how it is getting all together, and the concepts of circuit making, basically, right? Electricity, how the electricity is getting generated by using a simple, by making a simple circuit, and we have showed it in a little bit artistic mode, right? Okay. So yeah, there are multiple models which you can create using PHET. I'm again going to share my screen. And here everybody knows that PHET, I have told you many times, but whenever I open that PHET platform, always I get something new. So I always try to, tell that in one of the PPT about it, that please go and see the activities. You can actually feel, you can actually experiment it, right? Okay, Ruiji, yes. There are multiple LED center diya, yes. There are water diyas, right? That was a very nice experiment. Okay, just a second. Let me know if you can see my screen. Okay, all right. So what is happening over here is we are building a fraction. It's a very simple one. It's not only for the students, for your children also. It's a very fun thing for your children also, for your students also. You can please go and try this rather than just telling the example of pizza, right? Or anything, or just showing them the fraction. Let them try on their own. Just take a quiz kind of thing that you just have to open this and just ask the question and they will do it or by themselves. So what we are doing is doing a very simple one, right? Let's say for example I'm taking level 2. So here the question is given, right? It is written 2 by 4, how you are going to show it, right? So let's say for example I have taken a blank sheet and then I'll take this 1 bar and 2 bar. Okay, this is good. 1, 2, 3, 4, 5. I think I have done wrong. This one I need to take. Let me undo. This one was needed. 1 and 2. And we'll take this. And my answer is correct. So this kind of activity I'm asking you guys to do, right? 1 out of 5, for example, right? Let's take this and just take this over here. Okay, 2 out of 3. Let me take this. Okay, and see, it will not allow, right? So this kind of activities actually students find more interactive rather than, rather than just telling the concepts. See, simple, and there is level 3, 4, 5, and so, right? And you can go for the another level, you can go for the another thing also, the mixed one also, and so, right? So who finds this more interesting rather than just telling the concept of pizza, that okay, you have a pizza with 4 slices and take out, and like this I find much more interesting, while showing also, while while it's a playing mode. Just use your mobile phone and tell the students that okay, come here, you have to just give the answer of this kind of thing, right? Fraction tiles, yes, there are fraction tiles, etc. Yes, they grab the concept very easily by using such activities. Yes, absolutely correct, right? Geometry, I always prefer the clay, dough, and the sticks, right? This is the most amazing way of understanding 2D and 3D shapes. Don't you think so? Because telling the student only about, only giving a simple example, these circle, square, and everything is triangle is a 2D, and then cuboid and a cone is a 3D. They don't actually really understand. Even by giving the example of triangle and the ice cream cone and everything, they don't understand. But when they will build it by using the clay and the sticks, they will understand more, because they are touching it, they are feeling it, they are knowing the angles behind it, right? The corners, every single thing, right? Okay. Algebra, again I am going to show you the same screen is shared, right? Just a second. This is, let's say for example, in area, this is algebra over here. You can give the values over here, right? I was doing something, let me go back, go in this. Oh, sorry. We can search also, or I'll just. Is my screen visible to you guys? Just a thumbs up. Okay, fine. The PHET screen. Okay, okay, fine. So as you can see that the game is also given, variables with variables are also given, the generic also given, and you can just simply explore as well. Okay. So what you need to do is you can just change the numbers over here. You can even, see also, you can write also what will be the value. Okay. You can see what will be the cross values. You can even see what will be the answer and how the properties, the multiplication properties are getting used over here. You can change the values as well by just clicking here. Just a second. You can change the values, right? See, the model is very much visible. Up, right? So there are multiple examples which you can do, and you can make algebra also a fun over here, right? So there are multiple things. Please go and explore here. Let's go for the games as well. Okay. So now here the x value is here, the 9, the value is here. What will be the answer, right? You just have to write, or you just have to calculate over here. What will be the value? Correct. So how you can, the dimensions are also there, you can just check it. Let's say for example, I am writing 9 over here, enter, and check. No answer. What will be the correct answers, educators? Tell me so I can check it. What will the answers? Basically it is asking the answer maybe 18. Okay, 9. Okay, you can just solve it now. It is x plus 9 and multiplied by 3, right? What will be the value of x? Again, answer is 3x. We were actually thinking about only the number. Here it is actually telling here the answer is 3x. We have to show it on the model. We don't have to find the value of x. I also got confused. I thought that it needs a value of x, but actually it is asking in this corner what will come. So it is 3x. It was also already written over here. So there are multiple things you can do. Okay. Let's go back to the screen. Okay. I'm sharing the screen again, the PPT one. Okay, here is robotics basics in STEAM. Okay, what a student will learn? They will learn about sensor, motor, input, output. There are automation concepts. There are multiple things, right? What they can understand. They can go for the computational thinking as well. So there are something which I have written over here, like line follower, smart dustbin. Few of the activities I'll show, like line follower I'll show, smart dustbin also I'll show. Few of the activities which is not mentioned also, that also I'll show. Okay, so just give me 1 minute, please. Okay, I'm just removing the screen. Can you see me? See, I'm having one model over here. Okay. This is a microcontroller, which is known as microbit. Everybody here, please let me know if you know about microbit. Yes, it's a table lamp, sir. Yes, correct. So everybody knows about the microbit. It's a very, very versatile microcontroller. You can use it over here. So we have coded it, and even you can use it for AI ML projects. You can train the machine. You can use the AI ML projects as well. Okay, if anyone of you are interested in that kind of webinar also, I can take one webinar on microbit as well. Okay. How we can use the teachable machine, and then we can put the codes over here, and then your circuit will work, right? So here is the switch. There you are. And if there is no light, like if there is any darkness, then the light will turn on, see, right? And if, let's say, if I'm taking my torch on, the light will be off. If there is darkness, it's a very simple project, right? Okay, sure. I'll definitely consider this microbit one. Okay. So it's a very simple one, where just using the LDR, which is already inbuilt over here, the light intensity, which is already built in the microbit. We are just using it by coding it, right? I'll definitely show you the codes in another webinar. Okay. Then I would like to show, I need a good space over here because I have a full chart to show. Just give me 1 minute, please. This is our line follower, and this is the chart I am using for giving a path. Okay. Just let me know if you can see the screen. So this is the path I have given to my, let it come back, and it will get stop over here because I have given the stopping point. You can see the tape over here, right? It's a little bit a thicker one, so that is why it is getting stopped over here. Okay. If I'll move it forward, see, it will go and follow the path. Right? Let it come back. Come, and it will get stop over here. Stopped. Fine. There you are. Let me stop it. So how many of you have created line follower? Yes. Thank you, Ruhiji. Thank you. Yes. Okay, great. So please do try. There is a very normal coding for all kind of cars, whether it is obstacle avoider or line follower or light follower. There are multiple things which you can do, right? I tried, but it didn't work. Okay, I can share the code to you. Okay, do try this. Okay, it's a very nice project and it's never outdated. Okay. Yes. Okay. So if it is not working, or if there is any kind of problem in creating a path kind of thing, then that can be a problem. And line follower is something which where IR should be placed in a particular angle and particular way. So it's really very important. Okay. Definitely, I'll keep in my mind, and in next webinar I'll share the code. Okay. Okay. All right. Just a second. Yes, smart dustbin, I have already showed you many times, but if you will say, I'll definitely show you this time as well. Always use IR sensor. For IR is best for if you are making line follower. Okay. Yes. Smart dustbin, everybody knows over here. I've taken one webinar by creating the circuit as well. So you can see on YouTube, my webinar is there. Okay. So microbit I have already showed you. This is smart bin, definitely I'll show you, but right now it is giving a glitch to me. There is some kind of problem came. So this is a smart bin project. Can you see it? The servo motor is giving a problem. I just checked. So this was the model created. You can see over here, the servo motor is placed over here on the top for changing the direction of the flap. This is the nano board I have used over here. This is the ultrasonic sensor where it will sense that if somebody is standing, it will open it, right? And the cable is there. It's a very simple, very normal coding of using the just controlling the servo motor by using ultrasonic sensor. Okay, so right now it is not working. I'm very sorry, but definitely I'll show you one of the video of it. Just a second, just give me 1 minute. Can you see my screen? I'm sure you can see my screen. It's giving some glitch. Just a second. I'm sorry, it is giving a glitch. I'm sorry, it is giving a glitch. Sorry, it is giving a glitch. Can you hear me? Okay, all right. So I'm going to show you one of the project. Smart bin I have already showed you. Just give me 1 minute. I'm going to show you a project, a PBL, project-based learning. I have created here a smart home. Okay, just give me 1 minute. Just let me know if you can see me or a project. There you are. Okay, so here is the project. Let me adjust this. Okay, so the power cable I'm using, the power bank I'm using, and there you are. Okay. So what is happening over here? You can see the temperature it is showing. Right now I'm using my mobile phone, so please. Can you see clearly that what it is written? Okay, great. Here is, I have used a buzzer, a DHT11 sensor. Okay, there you are, a nano board. And here I have used a burglar alarm. You can see a laser light. If somebody is going inside it, so what is happening is an alarm is beeping. So this kind of project you can definitely ask students to create. Okay. Yeah. Just a second. Okay. Did you saw the project? Okay, all right. So please do create. If you have already created a smart home, very nice. If you haven't tried it, do try it. Okay. Okay, I'm sharing my PPT again. I'll show you the coding part as well for this particular project. Okay. Then let me know when my screen is visible. Okay. Okay, now we come to the part which is coding through play, and already know about the Scratch program and the Scratch and Blockly and Code.org. So actually why I have introduced this particular, if somebody doesn't know about the Scratch, you can please ask me. I can share the codings. I have multiple projects with me, right? You can definitely ask me. I'll definitely share it. I'll just show you. Just give me 1 minute. Okay, I'll show you the video. Don't worry. Okay, I'll show you the video. Okay, let me show you the video first. There you are. This is a smart home video.
Home. So first, we arrange all the components required in this activity. This is the laser light. This is output device. This is the LDR. This is input device. This is the buzzer. This is a output device. This is DST11. This is analog device. This is OLED display, and this OLED display is output device. This is the brain microcontroller. With the help of this brain microcontroller, we can control all these sensors.
This was the introduction of the sensors. See how they are creating it with the wires. They are creating all the, they are just attaching with the nano board. So this is one of our DIY kit. Otherwise, if you can definitely do with the loose components as well. Okay.
DST sensor module. So I paste this DST sensor model to left side gate of the smart home. So this is DST11. So I connect.
Okay.
So with the help of
this is how they are placing it.
And then select the activity.
This is one of the platform where we are going to use the coding part. This I'm going to show you. Okay.
Connect platform. Then you simply type your user ID and password. Then click on login. So this is your user dashboard. simply click on Tinker Orbit Coding, and first you need to create your activity. So here I enter the activity name, which is Smart Home Tinker Orbit. Then click on Create. This is work.
Okay, this Tinker Orbit is in place. You definitely see over there, and you can use the coding part. You use it for the coding part. Okay. No audio, no video. Okay, just give me 1 minute. Okay, just a second. I'm just going. Okay. I'm sharing my entire screen so that you won't be having any problem. Okay. Now can you see? Okay, I think there is some network issue. That is why it is not showing.
Then the buzzer will off. So let's start the code. So first I select the laser from the light block. So I select the laser block and select the condition, which is high or.
Okay, some issue is there. Just a second. Let me take it forward.
And humidity. So I select the OLED display.
Okay, some
block
issue is
from
coming with the recording. I'll share the coding part if you want. I will share the coding file as well.
I want this value printing on third line. Similarly, we take another block of OLED display and paste the humidity. So in OLED display, we can monitor the temperature and the humidity. So I select the humidity at line 4. As I already told that in the OLED display, there are 4 lines. So first represent the smart home, or we can say it's display the smart home, and in second line temperature and humidity. Now it's time to add
so
the
step by step all the coding is given over here.
From 400,
there are multiple things which you have to do for the smart coding, a smart home system. And then you have to upload it.
Click on setting, connect this cable to your.
After
refresh.
Uploading the coding part.
So in my system, the COM7 will reflect. Then click OK. Now with the help of this upload button, you can upload this code. And once the code will upload, then the sketch uploaded successfully pop-up will be shown, which means this code is up.
Okay. So I've already showed that how it will be working. Okay. So this is something which student will be learning. Student knows only the theoretical, student has only the theoretical knowledge, right? And then after creating this, they will be send video link after webinar. Sure. It will get live on YouTube. Okay. So you will get to know all of it. Fine. Coding has been done in what is the theoretical knowledge of or the principle of automation, sensors and controllers. After creating such kind of projects, they will be actually experiencing how the sensors will be done, will be utilized, how the coding will be done, what can be the errors, how they are going to create it, right? Multiple things. And it also consists the science, mathematics, technology, engineering and arts, right? Yes. Now, if you guys have any query related to it, you can ask me. Definitely, the problem which came in the video, that was a problem, right? I'll see how it can be shared to you. Fine. If it can be shared over here. No, I can't share it over here. I'll try. Okay. Yes. YouTube channel link, definitely. Once I'll get it, I'll definitely share it with you. Okay. So yes, so in today's webinar, my focus was only to show you some of the projects so that you can understand that how STEAM is actually working and how you can utilize this particular process of showing all the theorems and all the theoretical part in a presentation form and in a hands-on experience, right? Arduino and IoT are the site for learn coding and actually make sensors work. We would try it. Yes, sure, for sure. Arduino IDE is the open source platform. You can definitely try the coding for Arduino, and you can try the coding for Atmega also. You can try the coding for the Nano also. Definitely, you can try for multiple microcontrollers. If somebody is having any kind of question, you can ask. Please take webinar on microbit and share. Sure, sure. I'll definitely take one webinar on microbit. Okay. All right. So yes, I'll share. This is our certified STEM educator program. I always tell about it in my webinar. We are actually certifying the STEM, the educators in the particular field of STEM. And here you will be getting many information related to 3D designing and Python, robotics, Scratch, and app development. Okay, where you will be easily getting trained on these platforms of STEM, robotics, AI, coding, and IoT. Okay. So I'll share one link also so that if you have any query related to it, you can just ask it. Okay. Just give me 1 minute. I'll just share it. And I'm going to share the certificate link also for today's webinar. Okay. Do fill the form. And please share your experience. Meanwhile, I'm sharing the link. Please share your experience of today's webinar. Okay. You can check in the chat box. I'm just sharing the certified educator program. No, you will not get the access of webinars recording, but definitely you will get the recording on YouTube channel. Okay. Just one more thing I need to share. Okay. Your certificate details. Just give me 1 minute. And the certificate will get live after 20th of May. I'm repeating it. The certificates will get live after 20th. Okay. So after 20th, you can check your certificates. If somebody is having any problem, you guys, many of you have my number, so you can connect with me. Okay. Yes, all the necessary links are already shared. Please do share, do save it. Okay. Yes. And if you have any query, please, I'm open to discuss any query over here. Yes. Just a second. I'm sharing my number. If you're having any query related to the certificates, you can definitely ping me. Okay? All right. I hope you guys enjoyed today's webinar. You have learned something today. Okay. And if you have anything in your mind which you want me to take it to the next webinars, definitely you can put it over here. I'll see all the messages after this also. Okay. All right. Okay, Jyoti ji, you are saying that due to technical issues, you have missed previous webinars. That is fine. You can go to the YouTube channel of STEM Robo and search for the webinars. You will get all the links over there. Okay. Thank you, Ruiji. Thank you for your feedback. Nice. Thank you. Okay, everyone, let's meet through the another webinar. Whenever it will be there, you will getting informed over there. Okay. Okay. All right. Okay, Ashwarya ji. Okay, you are starting a robotics lab. Nice. Okay. All right. Okay. Great. Okay. Thank you so much. Thank you, everyone. Have a great weekend ahead. Bye-bye. Take care. Bye, everyone. Thank you for attending. Thank you for giving your time. Thank you, Ankita. Thank you, Abhijit ji. Thank you, everyone. Thank you. Bye. Thank you so much. Thank you, Pritam ji. Thank you. Bye-bye. Bye. Take care. Have fun. Enjoy your weekend. Bye.